Alright, in this video I'm going to teach you the basics of infinite sequences. Okay, so the main idea is that an infinite sequence is an ordered progression of numbers that goes on and on and on. Okay, so it doesn't stop. As opposed to a finite sequence is just a finite list of numbers or a finite list of terms. Alright, so these would be two common notations. So again, a finite sequence is a finite list of numbers, so we have a finite number of terms inside these two braces. And an infinite sequence is one that actually doesn't have an end to it, so that there are infinitely many terms in that infinite sequence. Okay, so there are a lot of ways that we have to represent or denote sequences, so notation-wise. So what you're basically looking for are two things. Okay, so if you encounter a new problem and you're thinking, what do I do? What does this notation mean? Okay, so two basic elements that typically will show up in a sequence are a starting point or term, and you also need a formula or rule. For getting the terms in the sequence. Oops. Okay, so again, a starting point, it could be a term. I'm going to go through examples, okay, but basically you need some kind of starting point and you need some kind of formula or rule for getting each consecutive term. Alright, so here's an example. So you see, you might see in braces like this, and some function of n given to you. Alright? So if the notation is like this, okay, so it's just some function of n with braces around it, the assumption is that n, the first, so you get, again, you need your starting point. Well, your starting point or your starting term is going to be found using n equals 1. Okay, so again, unless otherwise specified, the assumption is that you're going to start with n equals 1. So n equals 1. If n equals 1, we have 2 times 1, which is 2, minus 5, which is negative 3. So that means the first term in the sequence is going to be negative 3. Alright, so then to get the next term in the sequence, you have to follow the rule. Alright, the rule says you do 2 times n minus 5. So the next n value that we use is n equals 2. So then we do n equals 2. So when n is 2, we get 2 times 2, which is 4, minus 5, which is negative 1. To get the next term, we use n equals 3. So 6 minus 5 equals 1, and so on and so forth. Okay, so so lots of times you're going to be asked to, given some formula or some rule, to write out some terms of the sequence. Okay, so you just start with your starting n value and just keep increasing it by 1 to get each next term. Alright, so here's another example of a sequence. Alright, so n equals 1. Well, if n equals 1, this becomes negative 1 to 1, which is negative 1. So there's our negative there. And 1 over 1 plus 1, so 1 half. So negative a half. Then when n is 2, we get negative 1 squared, which is 1, times 2 over 2 plus 1, so positive 2/3. So each time we plug in, each time to get the very next term, we just increase the value of n that we're using by 1. So on and on and on and on. Again, just to reiterate my point, so last example here. So we start when n equals 1. So we have 1 minus 1 is 0. 2 to the 0, that's 1, times 4, it's going to be 4. So then when n is 2, we get 2 minus 1, which is 1. 2 to the 1, 2 times 4, we get 8. So basically this is saying each time we're going to multiply a term by 8. Each time we're going to multiply the term by 2, and then we get our next term in our sequence. Okay, this one actually has a special name. Actually does same with the first one here. That we will talk about in a little bit. Alright, so why don't you press pause while you find the next three terms in each of these sequences. Alright, for the first one, that corresponded to n equals 1, n equals 2, n equals 3, 4, and n equals 5. So now we need to find the term that goes with n equals 6, n equals 7, and n equals 8. Alright, so you can either use the formula, so when n is 6, we get 2 times 6, which is 12, minus 5, or 7. When n is equal to 7, we have 14 minus 5. And then when n is 8, we have 16 minus 5. Okay, so the next three terms would be 7, 9, 11. Or you might notice the pattern just among the terms themselves. Okay, so to get from -3 to -1, that difference is 2. From -1 to 1, that's 2. From 1 to 3, that's 2. So to get each next term, we can see from the pattern that what we're doing is we're adding 2. So to get the term after 5, we'll add 2, we get 7. Add 2, we get 9. Add 2, we get 11. Alright, now take a look at the second one. So we have n equals 1, n equals 2, n equals 3. So we need n equals 4, 5, and 6. For n equals 4, we have -1 to the 4th, which is positive. You can see that this is alternating positive, negative. That's called an alternating sequence. Okay, but we don't need that right here. All right, so it's going to be positive 4 over 4 plus 1, so 4 fifths. When n is 5, it's going to be negative, so -5 sixths. And when n is 6, it's going to be positive, so positive 6 sevenths. Alright, I'm just going to list the next two terms here because then I think you get the point here. So that's n equals 1, 2, 3. Again, we need n equals 4 and 5 because I'm only going to do 2. Right, so I actually mentioned the pattern a little bit ago, so let's just go ahead and use a pattern. So to get to each next term, we're just multiplying the term before by 2. So 16 times 2 is going to be 32. And then 32 times 2 gets our next term, so that's going to be 64. Okay, so you're not always going to have a nice pattern like this, but if you do, then it's helpful to get next terms instead of using the formula. All right, so let me just give you a bit of notation here that is common to see. So it's going to be common to see, for example, so I'll just give you an example. So a sub n is, say, 5 over n, and you want to list out the sequence. Okay, so you're going to see what this actually means is that it wants you to start off with n equals 1, plug it into this formula. So we get 5 over 1, which is 5, 5 over 2, 5 over 3, and then what we do to denote the pattern is that we would list a few terms, then comma, dot, 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 comma, put the general term here. Okay, so the general term means the formula. Dot, 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 infinity. Okay, so again, one more notation. You might just see this. Okay, so a sub 1, a sub 2, a sub 3, etc. Those are called the terms of your sequence. Okay, so for example, a sub 3 means the third term. Okay, so be comfortable with that subscript notation. Okay, so again, if you see a sub some number, it just means that the term that has that place in the list of sequences. Okay, so you're looking at the third spot in the list of terms. Alright, so now I'm going to talk about a few special types of sequences. The first type of sequence is called an arithmetic sequence. So you have an arithmetic sequence if there's a common difference between each consecutive term. Okay, you should probably pause to write that definition down. Okay, so for example, here we have -2 minus -6. That common difference is 4. 2, or that difference is 4. 2 minus -2, that's 4 as well. 6 minus 2, 10 minus 6. And unless they specify otherwise in the list of terms, the assumption is that it continues in this way. Okay, so one way to think about an arithmetic sequence is that if you take two consecutive terms and subtract in the same order, right, so the second term minus the first term, second term minus first term, if you get the same number each time, it's an arithmetic sequence. Another way you can think about it is you have some starting point and you add the same number to get each next term. Okay, so again, with some starting point, like -6 in this case, the rule is you add the same number to get each new term. So as I said a little while ago, all you need is a starting point and a rule or a formula. Okay, so the common difference again is whatever number you're adding to get the next term, right? So 4 is what we're adding to get the next term here. So think about, what are we adding to get each next term here? So we start at 6, then we jump to 10, then we jump to 14, we jump to 18. So each time we're adding 4. So that's our common difference. What about here? So we start at -5, then we get to -2. That's 3 away. -2 to 1, that's 3 away, 3 away. 1 to 4, that's 3 away. So the common difference here is going to be 3. Okay, so that's the way an arithmetic sequence works. Right, so the general form of an arithmetic sequence, meaning the formula, right, with some starting point, so A1, some specific number like 6 in this case, is the first term, and D is what we're adding to get each next one. Then the formula in general to find the nth term, so A sub n will be the nth term. It's just your first term plus n minus 1 times your common difference. So why don't you use that formula to find out what the general term is for this first sequence here. Alright, so the formula says to get A sub n, we're going to take the first term, which is 6 in this case, plus the common difference times n minus 1. So that ends up being equal to 6 plus 4n minus 4, which is equal to 2 plus 4n. So A sub n equals 2 plus 4n is going to be the formula to get all of these terms. Okay, so sometimes it's actually really helpful to have a formula, because maybe I know to get the next term I'm just going to add 4, but maybe I want the 200th term for some reason, and then I'm going to use this formula. Okay, so we can see it makes sense. For example, that's n equals 1, n equals 2, n equals 3. So when n equals 3, we have 4 times 3, which is 12, plus 2, which is 14. Okay. All right, so why don't you press pause while you find that formula. Okay, so in this case, we have -5 plus 3 times n minus 1, and that simplifies to -8 plus 3 times n. Okay, I encourage you to think about why it makes sense that this formula here is true. Alright, the next special type of sequence I want to talk about is a geometric sequence. So here the definition of a geometric sequence is that the ratio of consecutive terms is constant. So A sub n plus 1 over A sub n, so this means some term, A sub n plus 1, divided by, so the relationship between A sub n plus 1 and A sub n is that A sub n is the term before this, or we can think a sub n plus 1 is the term after a sub n. Okay, but the way I like to think about it is I've got some term and I'm going to divide it by the term before it. Okay, if that ratio is constant, then you have a geometric sequence. Okay, so for example, right here, we have 6, take a term and the term before it. So 6 divided by 2 is 3. Take a term divided by the term before it. That's 3. A term divided by the term before it, that's 3 again. Okay, so this is an example of a geometric sequence. Okay, so the common ratio is the way I feel like I have a useful working tool in thinking about the common ratio is I think personally, if I have a term, what am I multiplying each term by to get the next one? So for the 2, I'm multiplying by 3 to get 6, by 3 to get 18, by 3 to get 54. So my common ratio there is 3. Okay, so what is my multiplier? Here from 1 to -2, I'm going to multiply by -2. From -2 to 4, I'm multiplying by -2. Multiply by -2, multiply by -2. So here your common ratio will be -2. Right, what's the common ratio in this one? So it's going to be the same. Either you say 3 times what is 6, 3 times 2 is 6, 6 times 2 is 12, 12 times 2 is 24, or you can do, again, 6 divided by 3, 12 divided by 6, 24 divided by 12. In each of those cases, you get 2 as your answer, so the common ratio is 2. So once again, in a geometric sequence, we have a starting point, starting term, say. Each new term is determined by multiplying the given term by the common ratio. Okay, so over and over again we just keep multiplying by that common ratio, and that's how it's easy to figure out the terms of a geometric sequence. Alright, so here's the general formula for finding the nth term of a geometric sequence. So we have some starting term, a sub 1, and some common ratio. So this is our multiplier. Alright, so why don't you press pause while you try to find the formula for a sub n for that sequence. Alright, so this formula says to get a sub n, we will take the first term, 2, multiply by the common ratio, 3, raised to the power of n minus 1. Okay, so it's as simple as that. Alright, why don't you try these two? Press pause while you try them. Alright, for this first one we get 1, first term, times -2, the ratio, to the power of n minus 1, which is -2 to the n minus 1 like this, okay? We need the parentheses around that negative in the -2 because we need to raise the entire -2, the -1 also, to the power of n minus 1. Alright, the formula for this one is a sub n is 3 times 2 to the power of n minus 1. Alright, here's the last type of sequence I'm going to talk about. It's called a recursive sequence. So in a recursive sequence, each new term is defined based on previous terms. So here's an example. So a sub 1 is 3. So right, I said you need some starting term or some starting point, and then a formula for finding the other ones. So it says a sub n, so a sub n minus 1, that's the term before a sub n. Okay, so this is saying to get a term, I'm going to do 2 times the term before it plus the square of the term before it. So I have a sub 1. A sub 1 is 3. That's our first term. To get a sub 2, we're going to take 2 times the term before it. So 2a1 plus a1 squared. So that's going to be 2 times that given 3 plus 3 squared. So that's going to be 6 plus 9, or 15. Okay, why don't you press pause and find the third term. Okay, so to get a sub 3, it's going to be 2 times the term before, so 2 times 15 plus the term before squared. So that's going to end up being equal to 255. Okay, so the first term is 3, the second term is 15, the third term is 255. Right, here's another example. In this case, and some in other cases, you might be given 2 starting terms and then a formula based on those. Okay, so this is so it says to get a term, we take the one before it and then the 1 before that. Okay, so a sub n minus 1 is 1 before a sub n, and this is 2 terms before a sub n. So why don't you press pause while you try writing the first 5 terms. Okay, so the first 2 terms are given to us. Oops, that is not 2, it is 1. Okay, so a1 is 1, a2 is 1. Alright, so now we have the formula for a3. So a3 is, in this case, n is equal to 3, so it's going to equal a sub 3 minus 2, which is 1, plus a sub 3 minus 1, which is 2. So a sub 3 is a1 plus a2, so it's that term plus that term, which is 2. Again, we're just going to add the 2 terms before it to get it. Okay, so I'm going to do it the long way again for this next one. So a4, or a sub 4, is going to be a sub 4 minus 2, which is 2, plus a sub 4 minus 1, which is 3. So a2 plus a3 is 1 plus 2, which is 3. Alright, so now again, a5, we're going to take a3 plus a4, so we take the 2 terms before it, 2 plus 3, which is 5, etc., etc., etc. Okay, so that's the way a recursive sequence works.